Hey guys, we're going to finish up your OAD exam, the practice ones. That way you guys are totally ready for the test. So the very first question that we need to cover is from our chapter 10, I believe. Chapter 10, question number 3. So looking at this problem right now, I see that right here I have an index of 3 in both of those terms. That's important. But what I do notice is that one has the stuff underneath the square root of the first one is 5 and the other one's 135. Unless those numbers are exactly the same, you cannot combine them. They need to be exactly the same. They need to have the same index. They need to have the same, everything needs to look the same. We treat them like they were variables. So in this problem, we're going to take the cube root of 135 and we're hopefully going to break that down. So we look through our numbers, we see that we find a couple numbers that multiply to be 135 in our tree, and we have 5 times 27. 27 then can break down into 9 times 3, 9 can break down into 3 times 3, and I bring all my other numbers down. Now this index of 3 is very important. This tells me how many numbers I need in common in order to be able to pull one out. So because this is a 3, I need 3 3s in order to pull it out. If this was a 4, I would need a group of 4. If it were a 2, or you don't see a number, because with square roots you don't see numbers, you would need 2 of them. So looking at this second term, I have negative 3, and the cube root of 135 breaks apart into this group of 3 allows me to bring a 3 out. I still have the cube root, and because this 5 did not have 2 other partners, it's alone, it cannot be pulled out, that 5 stays in. In my original problem, I still had negative 2 times the cube root of 5, and there's my negative 3 times, and again, this second 3 came from that group of 3 that got pulled out. So now my problem turns into negative 2 times the cube root of 5 minus 3 times 3 is 9 times the cube root of 5. Now what you'll notice, I have the cube root of 5 in the first term and I have the cube root of 5 in the second term. Now they are exactly the same, so now we treat them just like variables. I am asking you, you have negative 2 cube roots of 5. You're subtracting 9 more cube roots of 5, which is going to give us negative 11 cube roots of 5. Again, treat this like it's a variable. Nothing happens to it. It's just like you would do negative 2x minus 9x. They get combined because they are exactly the same. So looking at number 4 is another question that we didn't cover. Here I've given you 2 functions. I give you the f function, and I also gave you the g function. What I'm asking you to do right here, please do not let this notation screw you up. What I'm asking you to do, this notation is really the exact same thing as me saying f of x plus g of x. I am asking you to add the functions together. That's all I'm asking you to do. So I'm telling you, take your f function, which was 3x squared plus 2x minus 9, and I'm telling you to add that to your g function, which was 3x minus 2. At this point, we look for your common terms. We combine them where we can. So I have x's in both of the terms. I have a constant in both of the terms. So combine them. We have 3x squared plus 5x minus 11. That is your f plus g of x. If I asked you to do f minus g of x, I'm asking you to subtract the functions. If I did f over g of x, guess what? I'm asking you to take your f function and literally divide it by your g function. And if I said something like f, and you'll see a star, maybe a dot in there, f times g x, just like the others, I'm asking you to take the f function and multiply it by the g function. Please do not let these notations throw you off. I am telling you to add, subtract, multiply, or divide the 2 functions. That is as hard as it gets. So flipping through, the next problem that we did not cover is problem number 9. So go ahead and flip down to question number 9. Second hour, I know you did not cover question number 8. I will come back to that. So question number 9. Again, we're looking here at multiplication. When it comes to multiplication, we have 4 times square root of 20 times square root of 10. Multiplication means everything gets multiplied. Remember what I told you guys off to the side. One big square root is the same thing as 2 little square roots. And that's more so important if I give you something like the square root of 1/9. That's one big square root. That's the same thing as 2 little square roots. And you can do that very quickly. Now again, your calculator can do a lot of this for you. So if you typed in 4 square root 20 times square root 10, you may get a nice number. You may not. It may come out as a decimal. It's your job to be able to know. You can either plug in all of these numbers and find the matching decimal, or if you're doing this in the written part, you need to know how to simplify. So here we have 2 small square roots. So I'm going to change this into one big square root. This becomes 20 times 10 under the same square root. Now I'm working with 4 times 200. Well, 200 is pretty big, so we've got to break this down. This is 100 times 2. We can break out 100 as 50 times 2, bring down that 2. 50 becomes 25 times 2, bring down that 2, bring down that 2. 25 is 5 and 5. Here's a 2, here's a 2, here's a 2. So I still have this 4 on the outside. This is a square root, so I'm looking for groups of 2. There's a group of 2, there's a group of 2, and there's 1 2 left over. So my problem then becomes 4. I have 1 5 that comes out from this group right here of 5s. I have a 2 that comes out from this group of 2. And I have a 2 that's left over that did not have a matching partner. So I start multiplying. 4 times 5 is 20. 20 times 2 is 40. And I still have that square root 2 in there. Your answer to that problem comes out to be D. Jump down to question number 11. This again still was chapter 10. So scroll down or flip over to question 11. This again is another chapter 10 question. Same type of problem. This case, I have all of my numbers being multiplied under one big square root. If it helps you to split it apart, split it apart. All of those terms get the square root attached to it. So when it comes to numbers, go ahead, do your tree. 25 times 2, 5, 5. 2 comes out. This is a square root, so I need a group of 2. There's my group of 2. 50 becomes 5 square root 2. X cubed, you need to think. I have 3 of them. 1, 2, 3. I need a group of 2, so that tells me 1 comes out, 1 stays in. Here I have 2 y's. I need a group of 2. There are none left over. Hopefully you also notice that squares and square roots, they cancel each other out, leaving me with a y. Well, we certainly can see that even though I simplified each one of the terms, that's not how my answer is written. So I take all my outside stuff that is not underneath the square root, all that stuff gets multiplied together. And then I take all my square root stuff, the square root stuff, and multiply those together. That's my final answer. That is why C is your choice. Now looking at number 12. Number 12 we talked about in class a couple times. We have done this question. You're looking at the football. It's thrown 30 feet per second. That's just how they come up with this equation. I gave you the equation. So if you want to think about how the picture looks, you've got this guy, and he throws the football, and the football kind of takes this parabola-like trajectory, and it lands on the ground. Okay, so what you have here is the football goes up, it reaches the vertex of this parabola type shape. So if you wanted to look at this as in a coordinate system, this is where the football starts. It's not on the ground when it's in someone's hands, but we're going to pretend. And then it hits its maximum, which this is time going on your x, and you've got your maximum height. So when you find the vertex, your calculator is going to find you an xy coordinate. Well, x right here, x represented time. So if I asked you all those questions, remember we did this on that one quiz where I said find your maximum height. Well, look at what's going on. What does this maximum height represent? Well, height is my y coordinate. This keyword maximum tells you that you're going to find the vertex. We also talked about the fact that this vertex has that axis of symmetry. So just as a side note, if it took me 5 seconds to get to the maximum, it's going to take me 5 seconds to get back to the ground. So this time thing, you can double, okay? This vertex, this x, this is going to tell you how long it takes to get to the vertex, which also tells you how long it's going to take to get back to the ground. That's the beauty of parabolas and why they are symmetrical. So in your calculator, go ahead, type in negative 16t or x squared plus 30t, x, graph it, hit your second trace, find so go to your calc menu, find your maximum, okay, find your maximum. Your maximum is going to give you this xy coordinate. Y is representative of the height, so if I ask you how high the ball got in the air, there's your answer. If I ask you how long that the ball is in the air, well, I'm asking you for this total x distance. You know how long it took you to get to the vertex, so double it. If it takes you 3 seconds to get up, you're going to take 3 seconds to get down for a total of 6. Let your calculator do